Perfect. Okay. Thank you for attending today. Today we're going to go over the Openshift technical deep dive. My name is Marshall Hall. I'm a field solutions architect with Tech Data, and I support the Red Hat brand. All right, so we're going to go over a couple of slides from last week's webinar that we did. Just to cover a little bit of ground for anyone that didn't make it to last week's webinar. When we think of Red Hat Openshift implementation, so Red Hat uses a 100% open source development model to deliver enterprise products with Openshift without forks, a platform rebase, or proprietary extensions. They are able to turn dozens and hundreds of open source projects into production-ready, stable, and secure enterprise projects that they support over many years. When the community declares a release ready, Red Hat typically finds hundreds of defects that they fix in the corresponding downstream releases. They can do this because they've been contributing to the Kubernetes project and many other projects that OpenShift is based on since day one. Red Hat is the largest enterprise developer of Kubernetes besides the project sponsor, which is Google, which is pretty impressive. So with this foundation of a trusted enterprise Kubernetes platform, Red Hat adds productive enhancements to deliver an application platform with all the components that are needed to fully deploy an integrated solution to build, deploy, and manage containerized applications. So in many ways, OpenShift is a smarter platform for Kubernetes because Red Hat is streamlining the installation and upgrade experience. With this platform, you can be up and running with a fully configured Kubernetes cluster in a matter of minutes. And you'll have everything you need from metering and monitoring at the cluster level, along with application and developer services. When we think about keeping the platform up to date and secure, Kubernetes updates, security patches, component updates, they can all be deployed with a single click. On the underlying foundation, based on Red Hat Enterprise Linux Core OS, OpenShift can actually update the underlying operating system and scale at the node level, which is particularly useful when you deploy OpenShift on cloud infrastructure because the entire cluster can scale up and down based on your application needs. So OpenShift 4 really can scale to support just a few containers or tens of thousands of containers. So we can see here in the slide all the benefits. So we have the core OpenShift Kubernetes engine. Then we have the OpenShift container platform sitting on top of that, and then OpenShift really provides advanced cluster management, as we can see in the slide, which provides a automated full stack installation and seamless Kubernetes deployment. All right, so moving on to the next slide. So this is a map of all the cloud native components that you would need to choose from in order to run containers in production. This is compiled by the Cloud Native Computing Foundation. This is the same open source governing body that is home to Kubernetes, which was the first project. It covers everything from infrastructure through application developer services, as well as the observability tools for the whole stack. It gets bigger and more complicated every few weeks when new revisions are rolled out. Just as a side note, this doesn't include serverless frameworks, which is a whole nother page. So anyone building their own container platform would have to vet, test, and select individual technologies throughout this stack, keep up with each component individually throughout its life cycle, and make sure that they all work together. Red Hat OpenShift does this work for you. They test and support the whole stack, including validated integrations for networking, storage, metrics, logging and monitoring, ingress, authentication and authorization, languages, frameworks, middleware, and databases. So it's all taken care of for you. So no matter what architecture you choose for application or what programming languages that the developers find most useful and what services you want to use as building blocks, Openshift provides a single, a consistent development model across the build, test, deploy, monitor, and review lifecycle of the application. So we see across this lifecycle, when we talk about self-service infrastructure, this lets the developers provision what they need on demand and skip waiting for hours, sometimes days, sometimes weeks for infrastructure resources. When we talk about consistent environments, Openshift makes sure that the environment provision for developers and across the lifecycle of applications is consistent from the operating system to the libraries, the runtime versions, and even in the application runtimes in use in order to remove the risks originated from inconsistent environments. When we talk about automated build and deployment, Openshift gives a choice to developers to build their containerized applications themselves or to have the platform build containers from the application source code or even from the binaries. The platform then automated deployment of these applications across the infrastructure based on the characteristic that the team has defined. The team can define the characteristics of the apps and how those resources should get allocated and where they should get deployed to be compliant with their licensing. When we talk about continuous delivery pipelines, Openshift provides out-of-the-box support for continuous integration and continuous delivery pipelines so that development teams can automate every step of the application delivery process and make sure that it's executed on every change that is made to the code or configuration of the application. For configuration management, configuration and sensitive data is built into the platform to ensure consistent environment agnostic application configuration is provided to the application no matter what technologies are used to build the application or which environment it's deployed on, or which environment we're deploying. And then last on the list here is application logs and metrics. This really provides our developers with rapid feedback during their development process. So Openshift has integrated monitoring and log management to provide those immediate metrics back to developers so they can study how the application is behaving across their changes, and they can be able to fix those as early as possible in the application lifecycle. All right. So one aspect we'll be demonstrating today is the ease of deploying and managing an application using Openshift. The first step is to create a project. This is the mechanism for grouping application resources. It also creates a namespace for a resource where all the resource names must be unique within a project. So when we create an application, we'll first create a project, and that project creates a namespace. Within Openshift, namespace or a project is very similar. It has a few differences to Kubernetes namespaces, but it's very similar, can be kind of an analog to that. Projects also allow us to create separate quotas and manage access policies within the project and between or across projects. So when we think about deploying applications, there's a few ways here listed on the slide, but there's several ways to actually deploy an application. So we can deploy applications from container images from source code where OpenShift would use an appropriate image. We can deploy an application from a base image plus source code. We can deploy an application from an OpenShift template or from a base image and binary artifacts. So this gives our developers a lot of flexibility in how they want to deploy their applications and how they work and how they go through their workflows. So one way that developers can deploy their code is using source to image. So I put together, or I found this slide for source to image. Source to image is a toolkit and workflow for building reproducible container images from source code. So source to image produces ready to run images by injecting source code into a container image and letting the container prepare the source code for execution. So by creating self-assembling builder images, developers can version and control their build environments exactly like they would use their container images so they can version their runtime environments. So it's very, very helpful for that aspect. And this automation makes it so that the development cycle can be increased and we can get applications out much faster. So with that, I'm going to stop sharing my screen here, and I'm going to start sharing let's see if I can. Oh, let's see if I can share the right screen. Always the technical difficulties with these live webinars. Let's see. All right. Now let's see. Where did that run off to? All right. Hopefully that's the right screen. So this is the web interface for our OpenShift cluster. So right now we don't have any projects created, and we just have an empty cluster. So what we're going to do is we're going to create a project. I've already logged into the cluster, but we can use the, nope, I guess I have to type it in the right way. We can use the OC who am I command to see who I am. We can use the dash show server to see which server I'm logged into. And we can do the show context to see which context I'm logged into. So these are helpful just to make sure we're in the right right spot. We're logged in with the right user. So we'll create, as I said before, we'll create our namespace or our project, and we'll verify that oh, we have created our project, and we will create our application now. And so what we're doing right now with our application, so we deployed an application, and this was deploying an application from source code. So I used the OC new app command, created the cake php-msq mysql-example command. I went through and created all of these services. So this application creates a MySQL database and an HTTP server. So if we look at the OC status, as it says at the very end there, we can see that it's deploying one service, or it's deploying the HTTP service and the MySQL service. We can look at the logs for the MySQL service. So this is the build process log. So we can see that it's right now building the MySQL service. And it should be finishing up in a few seconds. When we look in the console, we see we now have a project created. We see that on the right-hand side, it shows our messages, our events that are being created. So we have a couple of different places to look for these things. So we see that the build process completed successfully. Then we can look at the deployment process. We see that the deployment process completed successfully. Now we can look at when we do an OC get all, we'll see all the resources that are deployed within this project, within this namespace. So some of the interesting things that we can note is that we have 2 running pods. So we have our Cake MySQL example pod, and then my pod MySQL running. We have 2 replication controllers running. These replication controllers ensure that we have the predefined number of pods that we want to have running all the time. We have 2 services running, one for the HTTP server and one for the MySQL server. We have 2 deployment configs, again, one for the HTTP server, one for the MySQL server. The build config, build and image stream objects. These are managing the application's container images. So we gave it the source code repository here, and so it built the application from that source code repository. And then at the very bottom is the route. So we are so here's the route that was created. Here's the service endpoint. Oh, good old putty. The service endpoint that we can go to now. And there's our application. So this is just a simple demo application, but there's our service endpoint. So we can look at the pods that are running. So we see we have 2 running pods. If we just wanted to look at the running pods, we could give it the -- field selector and give it the status dot phase equals running, and I'll just show us the 2 running pods. So when we did the OC get pods, it showed us the build pod, which completed, the deploy pod, which completed, the pre-hook pod. So these are and the deploy pod for the different steps that it completed. So those are interesting pods that ran and then completed. So we'll see all of those. So we can also take a look at some of the services. So we can take a look at the MySQL service. We see that it's running on TCP port 3306. So one of the great things about Openshift is that this container now is running within its own environment. So we don't have to have, it doesn't have any dependencies. We didn't have to worry about the dependencies on this server. So if we think about the old way of deploying these applications, we may have had some problems deploying MySQL on the server. We may have had problems deploying an HTTP server because of dependencies or because of other applications deployed in this. Now we don't have to worry about that because this container is its own separate entity within Openshift. And so everything that's within this container is self-contained. There's no other dependencies. So this is a new paradigm that we have with Openshift, that we don't have to worry about any other dependencies of other applications. Everything that's running within this project is self-contained. So this is really a great thing that we have. We'll just take one more look at our route, and then we'll move on to the next part. So all right. So, all right, let me. All right, the next part we're going to talk about is the application probes. So with application probes, these really they improve the reliability and the availability of applications. So if we think about our applications, before, what we were doing was we were monitoring these, we were manually fixing problems, we were doing just a bunch of stuff manually. So OpenShift provides a lot of tools to help automatically keep track of these applications and these pods and automatically fix problems. So what we're going to look at today are a couple of things. So with application probes, there's 3 types of checks that OpenShift will do. So the first type of check that it can do are HTTP checks. So with the HTTP check, it will do well, just like it implies, an HTTP check. If it gets a return code between 200 and 399, it considers that a successful check. So this is good for web applications. when we think about the container execution checks, it's going to execute a command within the container. And if it gets a return code of 0, it's going to consider that a successful execution. So this is good. These are good checks for basic liveliness checks. And then there's the third check that it does is a TCP socket check. And this is where the kubelet tries to open a TCP socket to the container. So this is good for non-HTTP applications. So we have these three types of checks, and they all have one goal of trying to check to see if our pod or our container is working correctly. So with our liveliness probe, it's checking to see if the container is still running or not. So if the container fails the liveliness check, the kubelet is going to kill it. And then the next step depends on what the restart policy is. So if the restart policy, if the restart policy is to restart the pod, then it'll restart a new one. If not, then it just kills it. The readiness probes will just check if the container is ready to serve requests. If the container fails the readiness test, then it's removed from the list of endpoints. So this really controls which pods are available for service and which pods that Openshift is going to send services to. So those are really, those are the two key differences between readiness and liveliness. So just to kind of keep track of or keep that in mind. Here's some important settings. I just kind of threw that slide in there. So initial delay seconds, which is how long to wait after the pod is launched. Timeout seconds, period seconds, how long between rechecks, and then failure thresholds. So, all right. So now we're going to go into doing our check if I can find my notes. All right. All right, they're around here somewhere. Okay, so we're just gonna manually break our cluster. So within our cluster, we're gonna use the OC edit command. We're gonna edit the deployment controller. And within the deployment controller, so down here, we see that we have our liveliness probe and our readiness probe. So within our readiness probe, we have an MySQL command that it's trying. So what we're going to do is we're going to modify the username so that it will not be able to log in correctly. And once we do that, the readiness probe is going to start failing. So now we can see that Openshift has automatically detected the failure. It's started a second deployment, or actually, excuse me, it started a second deployment because we edited the configuration. So it's deployed this new pod that we edited with the incorrect configuration. So if we look in the console, we can see that now we have some messages that the readiness probe has failed after the container has been deployed. So we're just gonna watch this for a few minutes and see what it does. But in the meantime, let's see. We need to get, so we're gonna OC, we're gonna check the logs for, so we can see when we look at the logs now, we can see that it's trying to log in with this user and it keeps getting an error. So now, so this is one of the troubleshooting steps that we can do. All right. So it's going to take a few more minutes for this to fail. When we look at the pods within the console, we can see that the deployment pod was created for MySQL2. Here's the pod that's having the problems. We can see that the readiness probe has failed. We can drill down into that event and see more details. So we can see that the console is also helpful if you like the graphical view as well. So while we wait for this to do its thing in the background. So so as I was saying earlier about the you know, the old way of doing things, these applications would fail. We'd have no, maybe we wouldn't have any visibility into this. Maybe we'd make this change. Maybe we would make a configuration change. We would deploy our application, and we wouldn't have this visibility. And when I was a system administrator, we used to kid about the customer monitoring network, where our customers would call in and let us know that something was failing, or something to that effect. So we have all these different things where we don't really know there's a problem until much later. So this helps solve that problem by automatically identifying issues and addressing them much earlier than we would address them maybe normally. Or maybe if we have a decent monitoring system in place, but the monitoring system sends an alert, then it creates a ticket. That ticket goes to the help desk. A help desk analyst starts analyzing it. And then a couple hours later, it gets to the, after it gets routed to the right person, someone analyzes it. You're still looking at maybe a few hours of downtime while it gets routed around the company, finding the right person to fix the problem. And so a lot of these tools within OpenShift reduce that time. It reduces the downtime that we have for our applications. All right, now that I've beat that, so the next thing that we're gonna talk about while we're waiting for this to go is quotas. So we talked about having quotas within our namespaces. So we can look at the quotas. So I issued the command OC get applied cluster resource quotas. And then if we use the command OC describe, all right, so this is going to describe our quotas for our cluster right now. So our cluster, as we look at it, so this is a fairly young cluster, just created 2 days ago, or at least our quota was created 2 days ago. And we can see that the used column shows our limits for each of these values, and then we have a hard limit on the right side. So right now for config maps, we've used 3. We have a hard limit of 100. For CPU, we've been given 16 cores to use, and right now we're using 1.5 cores. So OpenShift measures cores in millicores. So that's 1,000 millicores for every core that we have. So right now we're using 1,500 millicores, or 1.5 cores. So we have 45 total gigabytes of memory. We're using 2.5 gigs of memory, 2,500 megs. Persistent volume claims, we're using 0 out of 15. Pods, we're using 3 out of 30, so forth and so on. So these are the quotas that we have been given on this cluster. So we can so we see that we can assign quotas based on projects or based on users, so that we can make sure that no one developer or no one project is taking over all of the clusters. When we want to look at the resources that we're using, we can use the kind of a long list. But we can use the OC get pods, and then the -- field selector equals status dot phase equals running. We can use the output selector of JSON and then pipe that to JQ, which gives us this output. And then this shows us all of the pods and the resources that they're using. So this is helpful when we're trying to determine, or we're trying to find out how many, what resources we're currently using versus our quotas that we're allowed, especially when we're starting to run up against quota limits. And we'll see that in a minute when we do that. But going back to our failure situation, so we can see that now that we've hit the failure time period, so our pod has reached the configured time that we've set, and it created an error on our deployment, and then it rolled back to MySQL 1. And so now we're back to running MySQL 1 with the correct configuration, and the cluster is now back to the correct configuration. So this shows the self-healing ability of OpenShift to overcome sometimes our ability to break things. So all right, so we'll just go ahead and stop our watch here. So now that we've taken a look at cluster quotas, I know that we're getting a little low on time here. So we're going to edit this, and we're going to set the quota, or we're going to set our memory way above what our quota is. If I can quickly find. Oh, I guess I went too far. All right, so now we're going to set this to, I'm going to set our web server to 50 gigs. All right, so now we're going to see, so now we have an error in our deployment because we went too far. We went too close to the sun. So we see when we look at the logs for our controller that the pre-hook failed because the lifecycle pod couldn't allocate the memory because the maximum memory usage per container is 6 gigs, and we set a limit of 50. So yeah, so it couldn't roll that container out. So we can remedy this situation on the command line actually, and we can set this, and then we can take a look at it again. Oh, let's do a watch. We see that it's deployed version 3 now. So it is, yep, version 3 is now deployed. So so we see now that it's running again. So those are the couple of examples that I have of automation within OpenShift. So we demonstrated the automation of deploying code from, or deploying deploying from source code to images. We demonstrated the ability of the self-healing ability of OpenShift. And then we also demonstrated some of the quotas within OpenShift. So with that, that is the end of my presentation. So thank you so much for attending today. And I don't see any questions in the Q&A. I don't know if anyone has any questions. I can let's see.